Hello everyone, this is Dr. Esperanza and I am going to be working on arithmetic and geometric sequence. You're going to be sitting in my classroom with my students in algebra, and for today we're going to be working on arithmetic and geometric sequence. So if you need more information and you need more practice on working with problems like this, stick around and sit in my classroom today. Algebra. We have arithmetic sequence and we have geometric sequence. And for the second part of our lesson, we're going to be working on a geometric sequence, a new type of sequence. And what is so special about this sequence? We're using a different formula. So from the arithmetic sequence, we have a sub n plus the quantity of n minus 1 times d. Here, the new formula is a sub 1 times r raised to n minus 1. So copy the formula down because that is what we're going to be using on the next set of sequences and series problem that we're going to be working on. And if you want to see or need to see more problem exercises on arithmetic sequence and geometric sequence, click on this I button right here so that it will show you some videos of my problem sets involving sequences and series. And we're back. Alright, so the first thing that you need to know, of course, is to understand the formula. What do you think is a sub 1 in this formula?
First term.
The first term. That is the first term, and it's still going to be the same symbol, but we have a new symbol here, r, and that is the common ratio. So in arithmetic sequence, we are subtracting. In this sequence, we will be dividing because ratio is synonymous to division operation in mathematics. So that is the special pattern that we're going to be looking for in geometric sequence. We need to find that common ratio because this one is no-brainer. You already know how to find the first term. So let's get started. So let's say we are asked to verify if this sequence is geometric. We're not asked if this is arithmetic, we're asked if it's geometric. So we're not going to subtract, we're going to be dividing. What is 8 divided by 2?
4.
4. And it needs to be common for every single term. So if I pick 128 and 32,
4.
it's equal to
4.
4. Because we have a common ratio. So if we divide every single term to the previous term, it will give us the same result, which is 4. And that is the pattern we're looking for. Everything, or not everything, but starting from 2, we are dividing 4, or starting from 2, we are multiplying 4 to produce the numbers, right? So that is your common ratio. So r is equal to 4 in this geometric sequence. Because obviously it's not an arithmetic sequence, because if you subtract 8 and 2, 32 and 8, 128 and 32, they're not going to be the same. Because it's not an arithmetic sequence, but a geometric sequence. So now that you know how to spot a sequence if it's geometric, can you please tell me if this sequence is geometric? 2 divided by 1, 4 divided by 2, 8 divided by 4. So they're all the same, right? So is this a geometric sequence then?
Yes.
And what is the common ratio?
2.
2. What do you notice about the sequence? Is it increasing or decreasing? Increasing. So what happens when your sequence or geometric sequence is increasing? What do you notice about the common ratio?
The number is lower.
The number is what? Is it positive or negative?
Positive.
Positive. So if your geometric sequence is increasing, expect to have a common ratio that is positive. Why? Look at this sequence. 27, 9, 3, 1, positive 1 over 3. Is the sequence shrinking or increasing? It is shrinking. Now, we need to verify if it's a geometric sequence. We need to divide 9 and 27. What's 9 over 27? Is it 3?
-3.
Is it negative 3?
Isn't that a fraction?
Isn't that a fraction? What? Tell me.
Pretty sure.
It is a fraction.
Yeah.
Because 27 cannot go to 9 evenly. So if you have a proper fraction, expect to have a fraction as an answer. You just need to simplify it. Can you simplify this? Can you simplify the fraction?
3, 9.
3, 10.
Right?
That's so easy.
Oh, 1/3.
That's how we simplify fraction, right?
I should-
So 1/3 is our fraction. Now let's try it. What about 1 divided by 3? It's already 1/3, right? Are they common?
Yes. So the combination.
So your common ratio is 1/3, so this is a geometric sequence. Now what do you notice about a sequence that is shrinking? What happens to your common ratio?
They become
Negative
fractions.
1/3.
Is this negative?
No. They
No.
become fractions.
But it becomes a fraction. So if it's shrinking, your R is fraction or proper fraction. But if it's increasing, your R is a positive number.
And that only happens with geometric.
Yes, it will only happen for geometric because we're no longer doing arithmetic. So don't overlap your arithmetic and geometric because they have a different pattern. In arithmetic, if it's positive, it's increasing. If it's shrinking, it's negative. But for geometric, it's a different form. Increasing is positive, decreasing is proper fraction. Now, increasing, decreasing.
Increasing.
So expect to have a common ratio that is a whole number that's positive. What is the common ratio?
2.
2?
Yeah.
2 or 3?
2.
2.
So it is 2. I need to make sure because some of you think that this is supposed to be 3 and not 1/3. So make sure that you know your basic math. And that is the reason why I always tell my students in any of my classes that they need to master their fundamental. And when I say fundamental, integers, multiplication table, and fraction operation. Because if you have mastered the fundamentals, you don't need to worry about doing those math work because you are already confident doing that math work. You just need to worry about the new concepts that you are learning in algebra, calculus, trigonometry, statistics. That's why don't take for granted your fundamentals. Okay? Now, is this shrinking or increasing?
Increasing.
Increasing. 1/2, -1, 2, -4, 8. But what do you notice about the signs?
It's positive.
It is interchanging, right? So let's see if this is still a geometric sequence. So let's follow the rule. Divide this to that, right? What is -1 divided by 1/2? But how do we do that? It's -1 times the reciprocal of the denominator. What's the reciprocal of the denominator? So what's 2 times -1? -2. Now, that's just the first one, but we need to verify it for the other one as well, right? So let's do this and that. What is 2 divided by -1?
-2.
Are they the same?
Yes.
Because they are common ratio, which fall under a geometric sequence. So what is your R here?
-2.
So what do you notice about the R of this problem number 4?
It's a negative.
If it's negative, what will happen to your sequence?
Decrease.
Oh.
For a geometric, just look at the pattern.
It's gonna go positive, negative,
It will be alternating. Positive, negative, positive, negative, positive, negative. But you know it's still increasing because 1/2, 2, and 8. All the positive numbers are still increasing. So this one is a negative positive number. And if it's a negative fraction, then it's alternating and it's decreasing. So that is why you need to know your patterns because that's what we're learning here. We're learning patterns and we're learning how to mathematically reason out what that pattern is. And recap, positive common ratio, increasing. proper fraction ratio, decreasing. Negative whole number, still increasing, but it's alternating. Negative, positive, negative.
And that will always happen.
And that will always happen for a geometric sequence. Okay? Alright. We're not done with this yet because we're just making sense on the geometric sequence given that they have a common ratio. Now let's work out problems involving geometric sequence. First problem. Write the first 6 terms of the geometric sequence with the first term of 6 and a common ratio of 1/3. So first, let's write the formula for a geometric sequence. What's the formula for the geometric sequence?
A-N equals A1
times R
N minus 1. Do we know the first term?
yes.
What's the first term?
6.
Do we know the common ratio?
Yeah, 1 over 3.
1/3. Now, we're looking for the first 6 terms, right?
Yes.
Which is 1, 2, 3, 4, 5, 6. Let's look for the first one, a sub 1. So if we're looking for a sub 1, we are replacing the a sub n with 1 and the a1 and the r with the given problems, right? So let's do the algebra. A sub 1 is going to be, what is a sub 1?
6.
And what is r?
1/3.
And what is what we're looking for?
And
N minus 1, right? So that is a sub 1, right? We just replace all the values
okay.
by the given problem because we're looking for this. Now let's do the math. What's 1 minus 1?
0, but isn't it not 0?
It's 0.
Then
Now, what is 1/3 raised to 0?
0.
Is it 0?
No, it's 1.
It is 1. You know your fundamentals. Good job. So 6 times what number then?
6 times 1.
And what is 6 times 1?
6.
That's why the first term of the sequence is 6. We just need to worry about the second term, right?
Yes.
So how are we going to solve for the second term? Same thing. A sub 2 this time, which is, what is a sub 1? Because it needs to be a sub 1 times r to the n minus 1. So a sub 2 is, what is the first term?
6.
What is r?
1/3.
And n is 2 minus 1, right? Always work out the exponent for first. What's 2 minus 1?
1.
And what is 6 of 1/3? You know how to multiply fraction. You just multiply across. Or, yeah, multiply across because this will turn into 1. 6 times 1 is 6. 1 times 3 is 3, right? Can we simplify this fraction?
2.
So the second term is 2. Now, for the sake of argument, can you please just give me a sub 3? You don't need to give me this, this, and that. Just give me a sub 3. Or the third term.
Ours can be 3 minus 1.
3 minus 1?
2.
And what is 1/3 squared? What is 1/3 squared? 1/3 times 1/3. And what's 1/3 times 1/3? 1 times 1 is?
1.
3 times 3 is?
9.
And what is 6 times 1 over 9?
6.
Can we simplify this?
Yes.
Yes. This is 2, 3. And this is 3, 3. Right? So it's 2 over 3. So the first 3 terms, what was the first one? 6, 2, and 2/3. Okay? So, what is the challenge of geometric sequence? Probably geometric is more complicated than arithmetic, and the reason why it's more complicated is because you are dealing with fraction. And expect to deal with fraction because you have the word ratio in your formula, and ratio is going to end up a fraction. Sometimes the fraction is easy to work with, sometimes it can be a little bit problematic, but it's doable. So that's what you need to expect when you're working with a geometric sequence. So we have 6, 2, 2/3, 2 over 9, 2 over 27, and 2 over 81 if we do the math all the way through. That's your homework tonight. Now, we're now going to find the nth term. And when we're looking for the nth term, we're looking for the formula, right?
Yes.
And the formula for this sequence is this. You're given the sequence and you need to find the formula for the sequence. And how are we going to write the formula? We need
First term,
and
The ratio.
color ratio.
that's all we need to figure out. Why? Because the n will stay the same. Can we do that? Okay. What is the first term in this sequence?
50.
No brainer. It's 15. We just need to figure out r. And the common ratio is this divided by the first. What is 75 divided by 15? 5. And let's see if it's consistent. What's 375 divided by 75? It's still 5. So the common ratio is 5. So now that we have the ingredients, we need to figure out the formula or the nth term. All we need to do is to plug it in. We're replacing a sub 1 and r with this.
Yes.
And we're done. A sub n is equal to, what is a sub 1?
15.
And what is r?
5.
Do we need to replace n?
I don't know.
No, because you're wanting the nth.
No, because we're looking for the nth term. If the question is, find the 7th term, do we need to replace the n?
Yes.
Yes, with
7.
a 7. But if it's the nth term,
You have to find that out.
now, can I simplify this further?
Yeah.
Can I multiply 15 and 5 so that I will have a simpler formula? So is a sub n equal to, what's 15 times 5? Calculator.
75.
75?
Yes.
So is this the same as this?
No.
No. In mathematics, you cannot multiply numbers with different exponents.
Oh, because the 5 has.
This one has an exponent of 1. This one has an exponent of n minus 1.
Okay.
You cannot combine them because you need to evaluate this first before you can combine it with 15. And since you cannot evaluate it or solve it or simplify it, that is your answer. So know your math fundamentals and laws of exponents. So we found the common ratio in the first term. The first term is easy because it's given. But the common ratio, we need to figure it out, and it is 5. Using the formula, all we need to do is to replace a sub 1 and r, and we're finished. A sub n, or the nth term, is equal to 15 times 5 to the n minus 1. We cannot multiply 15 and 5 because they have different exponent. This one has 1, and this one has n minus 1. And that's how you find the nth term. So, what if you need to find the 9th term? Can you see if you can answer this? With writing out the formula, a sub n, a sub 1 times r to the n minus 1. I need to write my ingredients, which is a sub 1 and r. And what is a sub 1? It is 7. I just need to figure out my common ratio. So I will divide 21 and 7, which is, and I will divide 63 and 21 to make sure that they are common, and that is 3. So I have a common ratio of 3. Now I'm ready to find what am I looking for? Nth term or specific term?
The specific
And what is that specific term?
9.
9.
So I'm looking for a sub 9. So by using the formula a sub 1 times r to the n minus 1, I will replace a sub 1, r, and n. Because now n is 9th term. So using the formula, a sub 9 is equal to, what is the first term?
7.
Multiplied by what is r?
3.
Raised to
And minus
9 minus 1, right? Because I'm looking for the 9th term. So now, I can do the math. That's the reason why I cannot combine 7 and 3 before, because you cannot multiply 7 times 3 and then raise it to the exponent.
No.
No, you need to use the exponent first, right? 7 multiplied by 3 to the
8.
8 power. And what am I going to do first? 7 times 3 or 3 to the 8?
8 to 3 to 8.
3 to the 8. And it's going to be a big number. What's 3 to the 8?
8 power?
You need to use the function, the exponent function. In some calculator, it's x to the y, or sometimes it's this symbol. And then you push 3 and 8 using that. And it's going to be 6561, which you're going to multiply by 7, and it gives you
I had the right answer with this.
45,927. So use your calculator and make sure it's right. So this is how we simplify this expression. So we have the first term of 7. We have r of 3. Using the formula, we're going to find a sub 9. And we know that we are going to evaluate the exponent first. So we have 7 times 3 to the 8. And the challenge is to use your calculator to produce 3 to the 8. And 3 to the 8 is equal to 6561. And you multiply it by 7. So it is 45,927. Saved. And that's finding the 9th term of the sequence. Now, on your own, can you find the 8th term? This time you don't need to find the common ratio because the common ratio is given. So what is the 8th term of this geometric sequence when your problem is giving you the clues and not the sequence? Okay, so let's solve it. Always write the formula that you need to use, which is a sub n equals a sub 1 times r to the n minus 1. You need to figure out your formula by finding a sub 1, by finding r, and what you're looking for. And in this case, a sub 1 is what?
Negative 4.
Negative 4. And r is?
Negative 2.
Negative 2. And what is the n that we're looking for here this time?
8.
8.
And that is because it's not the nth term, but a specific term, which is 8th term. So by plugging it all in, and that is your 8th term. So in working out with sequences and series, some problems are easy to work with, some can be challenging. The challenge in geometric sequence is knowing your exponent and knowing your fraction. So geometric can be a little bit more challenging than arithmetic sequence, and expect that. And also, most likely, you will be using a calculator to produce an answer in the geometric sequence because you need to multiply big numbers. So arithmetic and geometric sequence, the problem sets will still be the same. You might be looking for the nth term or the specific term, and sometimes the given will be different. Sometimes the given is a sequence of number. Sometimes the given will be the clues, which is explicitly given by the common ratio and the first term. And that is how you work out problems in geometric and arithmetic sequence. And again, if you need to have more examples on arithmetic and geometric sequence, just click on this little icon right here and it will show you some of my videos on how to answer arithmetic and geometric sequence to learn more about the workshop that we just did today. And again, this is Dr. Esperanza, and thanks so much for sticking with me, and I hope that you learned your lesson on arithmetic and geometric sequence. Please like, share, and subscribe to my channel, and see you all on my next workshop on mathematics. Bye!